Okay, good morning, everyone. We're gonna get started. Looks like we got about 10 people here, nine people. So yeah, we'll just jump into it. Yeah, I hope you had a good break. Yeah, I kind of had a bit of a boring March break, all things considered, but it was pretty good. Yeah, just watched a lot of TV and played some video games and kind of puttered around the apartment and did some projects and cleaned and that kind of thing. Um, oh, whoa, hold on a sec. I've got to mute myself. I don't want to hear myself. There we go. That's better. Okay. So yeah, we're gonna start a new section. So I want to just tell you a little bit about what to expect. So yeah, there's been a few updates about the school situation, and I'm sure you've already heard them, but I just want to make sure that everyone knows where to access this information. So I did put a little update on my website. I'll get you to just do that on your own time to check the website. I'm kind of assuming that if you're here or you're watching the video, then you probably already have checked the website, or at least have kind of heard that we still are gonna finish the school year. We're just gonna finish it kind of the way we're doing it right now, unless we're told otherwise. So yeah, we're gonna just keep doing this. I'll be logging into YouTube every day at around the same time. As per my website, I've kind of decided that we're gonna start at 10:15 and we're gonna go for 45 minutes. I think 45 minutes is a good amount of time, just based on how things went the week before March break. I think that after 45 minutes, my voice was getting a little tired. This is a little different than a regular class, right? Because it's really just me talking to you. It's very one-sided. So 45 minutes straight is I think it's plenty long enough. So we're gonna stick with 45 minutes. A couple other things just to be aware of. I did post on my website just a little note about math help. And I was very pleased to hear that lots and lots of students were reaching out to me for math help, asking for clarification, that kind of thing. The thing is, just because I'm at home all the time now and everyone is at home, I think it's important that we just set up some boundaries just about when I'm going to communicate with you. Because there was a few nights where I was just kind of messaging students, like not one student in particular, like no one has done anything wrong. I'm not trying to make anyone feel bad, but there was just a few nights where there was just lots and lots of students who were asking me stuff quite late into the night, and I don't think that that's sustainable. I can't do that every night. So what I'm gonna do going forward is just answer your questions during the school day. So I'm going to be sort of considering my Monday to Friday 9 to 5 to be the time that I'm working. So if you have any math questions, that's the time that I'm going to be answering them. So if you want, you can ask me a question at any time. So if you're like if it's midnight and you're in the middle of a problem, don't hesitate to send me a message, but you may not get a response until like 9 a.m. the next day. If it's on a weekend, I'll probably wait until Monday. That said, if there's a big assignment coming up or something like that, I'll probably bend the rules a little bit. But just as a rule of thumb, I just want everyone to be aware that I am going to try to just fit everything into the regular school day, just so that I have some clear boundaries to myself about when I'm working and when I'm not working, because it is easy to sort of blur the lines when you're working from home. Couple other things. So I have a Discord channel, and I think I did mention it. Looks like we have one person on Discord right now, so that's great. If you want to head over to Discord, there's an invite link on my website, so go check that out. The main difference between Discord and YouTube is that you can ask questions live with your microphone if you wanted to do it. Another slight difference, and this one might not really mean this same thing, but the lag is much less. There's about a 30-second lag on YouTube, but there's like less than a 1-second pause on Discord. So not that really means much to you as a viewer, but if you are interacting, like even on YouTube, if you type a text comment or whatever in the chat, I don't see that until about 30 seconds after. Well, you don't see my response until about 30 seconds after you type it, so it's not super live. So if you want, you can head over to Discord. But if you're comfortable just using YouTube, that's fine too. Whatever you're most comfortable with, that's okay. Last update as well, and this is certainly the most important update, is to our assignments. So I still haven't received everybody's assignment, so I'm not going to return them yet. But yeah, so I'd like us to start using Google Classroom exclusively. So in the last assignment, it may have been a little confusing. You'll just have to bear with me because I'm learning this too as we go. So this is a learning experience for me. I in the last assignment, what I did was I had sort of two ways that you could hand it in. One way, you could just go to the website, fill in the Google form, upload some pictures of your work, and be done with it, and then not even have to use Google Classroom at all. Alternatively, you could have gone to Google Classroom and then submitted the assignment, and part of your submission would be the Google form and then whatever you uploaded using Google Classroom. So that may have been a little confusing, and I didn't really realize that this would be the case when I set it up this way. But it turns out that kind of was the cause of a little bit of confusion, because some people handed in the Google form using the website, but then Google Classroom said you haven't handed in the assignment yet because you didn't do it through Google Classroom. So a few students were reaching out to me asking, hey, I think I handed in the assignment, but Google Classroom says that I didn't. So going forward, we're just going to use Google Classroom. We're not going to use the website for assignments, just to make it clean and clear about whether or not you've handed it in. I think Google Classroom has a lot of really cool features that I look forward to using. I'm not going to use all the features for this assignment because some people handed it in through the website, some people didn't, so I can't really take advantage of those features without just singling out a certain group of people who did hand it in through Google Classroom. So I'm just going to sort of basically use your Google form entries as the main source of your grade. So I'll use that. Going forward though, in the next few assignments, what I'm going to do is I'm going to ask you to upload all of your images and stuff using Google Classroom, and that way I can actually mark it and like give you check marks and write some feedback and that sort of thing. So I do look forward to using that. I think there was one more point. Oh yeah, and this is another point as well. I'll be writing an announcement on the website fairly shortly about this, and it is a pretty big announcement. So I think a few people were unhappy with their the way the first assignment went. The one with sequences and series. So I think what I'm going to do is I'm going to give students an opportunity to replace that grade with something else. So I still haven't decided how it's going to work. You have to understand that with bonus assignments and things like that, it's a heck of a lot of work to come up with an extra assignment that not everyone necessarily wants to write, because I still have to make the assignment, I still have to grade it, And I also have to do it in a way that's fair to everybody as well. Like I can't just give it to a few students who want to replace their grade with something else. I do have to give it to everybody. So yeah, so stay tuned about that. I wanted to do something like that over the break, but then I also sort of realized that it's a break, and I think that all with everything going on, then I think we really could use a solid break. So I'll try to come up with something by the end of the week about a bonus assignment, and that way you can try to increase your grade a little bit, or at least sort of replace the grade that you got for the sequences and series assignment. So yeah. Okay, so now let's actually get into today's lesson. So we're gonna be talking about radicals for the next little while. So we're gonna put quadratics behind us for the time being. You'll notice that on the website, the quadratics is now sort of like its own tab. So I've sort of archived all of that material. So we're gonna look at radical operations, and I want to start off by talking about one of the biggest misconceptions in radicals, and probably one of the bigger misconceptions in all of mathematics. I think that the number of people who I see get this wrong is surprising. And it's not even so much the number of people, but it's who I see get it wrong. And I see like a lot of math teachers get it wrong. I see a lot of like very experienced grade 12 students who are know a lot of mathematics, but it's a kind of like a it's almost like a common spelling mistake. It's not like this huge misconception that means that you don't understand anything. It's just one of those things that it's like, I'm surprised you don't know how to spell this very common word. So I want to show it to you, and I just want to be very clear about it going forward, because I think that this sort of spelling mistake can lead to sort of bigger problems later down the line. So the problem comes from here. So we're going to talk about radical operations. I think that we can see, based on everything that we've done with quadratics, that the first question that I'm asking here, to solve x squared equals 9, it has two solutions, right? It's got so x would be plus or minus 3, right? And I mean, if you wanted to, you could graph this, right? This would be x squared minus 9 equals 0. So then it would look something like this, right? And then you'd have minus 3 over here and positive 3. So essentially what you'd be doing is you'd be finding the roots of this quadratic. So because this is a quadratic, we would call this a square. And then these over here would be the roots of that square. So you could think of this as the square root. So you could say, oh yeah, the square root of 9 is plus or minus 3. And that's sort of true. Yeah, in fact, it is true that the roots of this square are positive and negative 3. So you could say that the square root of 9 is plus or minus 3, and you wouldn't be wrong. But the source of confusion is when it comes to something like this. So let's solve something that looks very similar. This is x equals the square root of 9. And when I say the square root, I'm being a little bit misleading. I'm being a little misleading because this is what we actually call the principal square root. And that's what this square root symbol looks like, this radical sign, this sign right here. This means the principal square root. So in this case, x is just equal to 3. It's not plus or minus 3. It's just 3. And that's because it is the principal square root. So we're not asking for solutions to the equation x squared equals 9. What we're looking for is just the positive version of the number when you square it, that you get 9. So that's what the principal square root is, and that's what the square root symbol looks like. So just going back to the misconception, it is not plus or minus 3. It's just positive 3. So this is a huge source of confusion. because we're used to taking positive and negative versions of the square root, and rightly so, because -3 squared is still +9. So you would think that that would be the solution, but remember that this is just a single number. So when I take the square root of a number, I'm really just taking the principal square root. So this is what we call the principal, and it's principal with an A, like the principal of a school. So this is the principal square root. And anytime we take any square root at all, it's always the principal square root. That's what that symbol means. So so let's just talk about a little bit of terminology. So let's go over some definitions. So I'll just write here definitions. Okay. So there's a few definitions I want to cover here. So this is called. So let me just write a few things. So I'm going to say that if x to the power of n is equal to a, then what we say is that x is equal to a to the power of 1 over n, and that is equal to the nth root of a. Okay. Okay, so let's talk about what some of these symbols mean. Okay, so first of all, we say, so the nth root of a is called a radical expression. Okay, so we've got a radical expression. That's what this is called. This is called the radical symbol. It's called the radical symbol. The thing underneath the radical symbol is called the radicand. Okay, and n is called the index. Okay, so just to make one nice little picture, if we have the nth root of a, well, a is called the radicand, n is the index, the square root symbol is called the radical sign, and the whole thing is called a radical expression. Okay. Okay, so let's do some examples and see what the questions that I'm gonna ask actually look like. Okay, this looks good. Okay, perfect. So let's take a look at this one. Okay, so let's solve for x here. Okay, and I'll make it nice and big. So if we solve for x and we say that x squared is equal to 4, well, when we solve this, what we can do is we can say that x is equal to plus or minus the square root of 4, or in other words, x is equal to plus or minus 2. So you might say, well, hold on a second. Well, I thought that when we take the square root, it's just the positive version. No, 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 no. When we look at this equation here, we're squaring x. So that means that x could be positive or negative, and it doesn't matter which one we get. X could be positive 2 or x could be negative 2. So it's more like when we introduce the square root symbol ourselves that we we have to introduce the plus minus symbol. So just something to be aware of. Now, what about something like this? What if we had x cubed equals 8? Okay. Well, let's think about that for a second. Well, x is going to be equal to, in this case, just the cube root of 8, or in other words, that's just positive 2. The reason for that, the reason why we don't have any negatives there, is because if a is less than 0, so in other words, if a is negative, then a to the power of 3 is also negative, right? Because we would have a negative times a negative times a negative. So a negative times a negative is positive. Give yourself another negative and you've got, well, now you've got a negative. So really what we're going to be looking at here, and what we'll notice in a second, is that what we call in math the parity of the exponent. And when I say parity, I'm meaning odd or even. So really what we're going to be looking at is, are the exponents odd or even? And that really plays a huge role in what we're doing. So let's take a look at a few more examples. Let's try this one here. So let's do x to the power of 4 equals 16. Okay, well here let's take a look at this. If x to the power of 4 is equal to 16, well, that means that x could be equal to plus or minus the 4th root of 16, which happens to be plus or minus 2. And that happens because 4 is even, right? So 4 is even, which means that even if x is negative, if I take a negative number and I take it to the 4th power, well, all those negatives are going to cancel out because they come in pairs of 2, right? So we'll have a negative times a negative, which is positive, and then a negative times another negative, which is also positive. So I've got a positive times a positive, and I get positive. So really what we're doing here is we're looking at, okay, how, like, what numbers can I put into these brackets to get positive 16? Well, certainly I could get 2, like positive 2 times positive 2 times positive 2 times positive 2, that's 16. I could also put a negative sign in here, right? Because these two together would give me positive 4, and these two together would give me another positive 4, and 4 times 4 is 16. But you can imagine that if we were looking at the 5th power, we would have a bit of an issue because we don't get pairs of 2. So as long as our exponent is even, when we take the 4th root of something, we're going to get a plus and minus version of that solution, if that makes sense. Okay, so I'll kind of leave some of those. How about this one? Can we do this? Okay, so x to the power of 4 is equal to negative 16. Let's see if we can solve that one. Well, is there any number that you can punch in here that gives us negative 16 when you take the 4th power? Well, no, there isn't. Not in the real numbers. So there's no real solution. So here we'll write no real solution. Okay. So yeah, there's no real solution to that one. Okay, but what about this one? Okay, let's try this one. Let's do x to the power of 5 is equal to negative 32. Well, yeah, there is a solution to that. Again, I maybe you've already sort of figured out my pattern. I'm just looking at powers of 2. So 2 to the power of 5 is 32, which means that negative 2 to the power of 5 is negative 32. So I'm going to get this little fact that x is equal to negative 2. So you'll notice that whenever our exponent is negative, or sorry, not negative, whenever our exponent is odd, we're always going to get, just one solution. But when our exponent is even, we'll either get two solutions or no solutions. Okay, I want to cover a few more rules of these radicals. So let's just write some of these guys down. So let's write, let's call them properties of radicals. Okay. Okay, so we've got properties of radicals, and I've got a few different properties. So the first one, and this is something that we're going to explore a little bit more later on. So I know that I've already sort of written it down, and maybe you've already seen it, but we will investigate this fact a little bit more in the future. But I think it's a cool fact that a to the power of 1 over n, excuse me, I got the hiccups. A to the power of 1 over n is equal to the nth root of a. Okay, so we can actually write radicals with just exponents. The only thing we need is just to have a fraction as an exponent, and it's not just 1 over n. We can have pretty much any exponent that we want, or sorry, any fraction we want. So if we have a to the power of m over n, well, what that is equal to is a to the power of 1 over n to the power of m, or in other words, this is equal to the square root, or not the square root, the nth root of a, all to the power of m. And I'll just move this equal sign here. Yeah. And this is all consistent with our rules of exponents. So if you're remembering some of the rules of exponents that you have, you might remember that when you have two exponents, one on either side of a set of brackets, you multiply them together, right? And 1 over n times m is m over n. So that it is consistent with our rules of exponents, and they'd better be, right? If you had a new rule that contradicted old rules, then you'd be in trouble. Couple more quick rules, and again, these kind of just boil down to the exponent laws, but it's important just to write some of these things down. So a to the power of negative m over n is equal to 1 over a to the m over n, which is equal to 1 over the nth root of a to the m. Okay, and I think I've got one more that I want to show you, and this one's quite important. And we did sort of like look over these very briefly when we were looking at the quadratic formula. Some of these facts we just kind of had to assume, but now we're really just jumping into the details. So this last rule is that the nth root of a over b is equal to the nth root of a over the nth root of b. So in other words, the radical of a fraction is a fraction of radicals. So it distributes the way you think it would. And you know what? I'm going to include actually one more. So I'm going to say that the nth root of a times b is equal to the nth root of a times the nth root of b. And there you have it. So those are all the rules that we need. So let's just do a few more examples. Let's try. Yeah, let's simplify some radicals. Okay, so we're gonna simplify these guys. So simplify. Okay. So let's simplify the square root of 9x squared. Okay. So we're going to simplify the square root of 9x squared. Well, this is the product, so I'm gonna split it up. So this is equal to the square root of 9 times the square root of x squared. Okay, so this is going to be equal to, well, the square root of 9 is just 3, right? It's a principal square root. There's only 1, so we just get 3. And now we've got the square root of x squared. And you may be tempted to just say, oh yeah, well that's easy. It's just x. Let's think about that for a second. Is the square root of x squared equal to x? And it seems like it must be. It must be equal to x. But I hate to break it to you, it's not quite that simple. What happens if x is negative? Like what happens, like let's say if x is equal to negative, let's say negative 5, right? Because x is a variable, it could be anything. So we do have to make sure that this is consistent in all cases. So if x was equal to negative 5, well, then we would have, let's just consider what this would be equal to. Well, then you would have, you would have the square root. Oops, no, we're all good. We would have, well, negative 5 squared is positive 25, and the square root of 25 is just 5. So all of a sudden we get a positive 5. And if x was positive 5, we would get the same thing, right? We would still get positive 5 as our answer. So you may remember a little while ago we did something about absolute values. So this is where absolute values really come out to shine. So this is going to be the absolute value of x, because no matter what, we're going to get the positive version of x, because we're going to square it and get the positive version of it, and then we'll take the square root of it. And you can only take square roots of positive numbers, at least in the real numbers. You can only take square roots of positives. And when you take a square root of a positive number, you get a positive number back. So we're going to get 3 times the absolute value of x. Okay. Okay. So let's move on to the next one. So let's try. Let's take the square root of x to the power of 5. Interesting. Okay. So let's see what we have to do here. So I'm going to write this in a slightly different way. I'm going to say that this is equal to the square root of x to the power of 4 times x. And you'll see why I'm doing that in a second. The main reason is that I'm taking the square root, which is like, I think of like the second root, like if I'm thinking of it in terms of like the nth root. In other words, I'm imagining this 2 here, and I'm looking at 5 and I'm taking the biggest multiple of 2 out of 5 that I can, which is 4, and then I've got 1 left over, so that's where that x is coming from. So when I write this down, I'll get, well, I can split this up, so this is going to be the square root of x to the power of 4 times the square root of x, or in other words, this is equal to the absolute value of x squared. Or hold up. Let's just write this, and then we'll talk about whether or not we need the absolute value symbol. And this is equal to the square root of x. So I've got the x squared times the square root of x. And I kind of hesitated there about these absolute value signs, and I put them there just out of habit, but then I realized, hold up, I don't think we need those absolute value symbols. And let's talk about that for a second. So do we need absolute value symbols here? Well, the short answer is no. And the reason for that is because even if x was negative, well, first of all, if x was negative, we would have a problem here, and this would be undefined, right? So that's one thing to keep in mind. that this whole expression is only defined when x is positive. It's only defined when x is positive. Because if x was negative, we would have this square root of a negative number here, and we wouldn't be able to get it. Or in other words, if x was negative, then x to the power of 5 is also negative, right? And then we would have the square root of a negative number, which would be a problem. The other reason why we don't have to write the absolute value symbol is because it doesn't matter, because even if x was negative, when we square it, right, because we're squaring it here, even if x was negative, when we square it, it would become positive again. So so that's something to keep in mind. Okay. Let's do a couple more questions, and because we started at 10:15, we're gonna go to 11, so we got about 10 minutes left. Let's do this question. I think this is a good question. Let's try square root of 16 x to the 6 y to the 8. By the way, my calculus professor showed me this trick a long time ago. Well, not that long ago, but the idea is that sometimes, like, if you're writing a square root symbol and you do something like that, it's like, well, is the x part of the square root? Is the y part of the square root? Are the exponents inside the square root or outside the square root? So he showed me you could do this. What you can do is make your square root symbol, and when you kind of like draw the roof of it, keep going and go a little bit past your last number, and then make a little notch down. And that just makes it completely clear where your square root symbol begins and where it ends. So I highly suggest that you take that little tip with you wherever you go, because it's so, like, it's unambiguous, right? Because you know exactly where your square root ends. So please do that. Okay, so let's write this. So the square root of 16 is just 4. So why don't we do this? Why don't we split it up into its different products or its different factors? So I've got the square root of 16, and I've got the square root of x to the 6, and I've got the square root of y to the 8. Okay, so square root of 16 is 4. The square root of x to the power of 6 is the absolute value of x, and this x, I should say x to the power of 3, and the square root of y to the 8 is the absolute value of y to the power of 4. But let's think about this for a second. Do we need the absolute value around y to the 4? Well, no, we don't, because even if y was negative, when we take it to the 4th power, that is going to make it positive anyways. So we can get rid of these brackets. So I'm going to write this out kind of a little bit more neatly. This is 4 times y to the power of 4 times the absolute value of x to the power of 3. Okay, let's keep going. Okay, yeah, I like this. Okay, so I think that we can probably do 2 more examples. Let's do this one here. I've got a little textbook on my computer here that I'm kind of stealing questions from, if you're curious. Let's do... Yeah, I'll do this question because I think this is a good question. So we're going to simplify and assume that all variables represent positive, not positive, real numbers. Just real numbers. Sorry, I misread. So no complex numbers. Really, that's just saying is that if we're forced to take a negative or something, the square root of a negative number, it's not that there's no real solutions, is that there's no solutions at all, because these are explicitly real numbers. I'm gonna rewrite this. It looks kind of ugly. Represent. It doesn't look much better. Okay. Let's do this one here. So I'm gonna do the square root of x minus 2 squared. Okay. Well, there's really not a whole lot that's different about this than some of the other ones. Like if we were to do this just on the side here, if we were to do the square root of y squared, that would be, well, the absolute value of y, right? So it's going to be the same thing. In this case, like if you wanted to, you could say, okay, well, let y equal x minus 2, and now you've got the same thing, right? It would be just the absolute value of y, but in this case, y is equal to x minus 2. But if you don't like thinking that way, that's fine. What we'll do is we'll just say, okay, this is just the absolute value of x minus 2. And that's that. Let's see here. Let's try one that's really similar to it. Let's take the cube root of x minus 2 cubed. Okay, well, in this case, we don't have to worry about positives and negatives because we're taking the cube root. So when we take the cube root, there's no issues with taking a negative of a cube root because you've got an odd number, right? So this is just going to be x minus 2. And I think we'll do one more. I think we've got time for one more example, and I think that this is a really great example here. So let's do this one here. So I've got the square root of x squared plus 4x plus 4. Okay, and oh, look at that. Isn't that beautiful? This is something that we can factor, right? So this is equal to, well, the square root of x plus 2 times x plus 2. Oh, look at that. X plus 2 times x plus 2, that's equal to x plus 2 squared. And look at that. So this is something that we pretty much have already solved. This is the absolute value of x plus 2. So I hope that's a nice little intro to radicals. I'm going to sign out in about 2 minutes. I'm going to put a little bit of homework on the website just for you to try for yourself, so you can make sure that you're able to keep up with without any hiccups. If you do have any problems with the homework, please let me know. Let me know as soon as possible. Like I said, if you leave the homework to midnight tonight or something, and you ask a question, that's fine. But you're not going to get a response until the next day, probably. I mean, it really depends. I mean, like if I can't sleep or something and I have nothing else to do, then I might answer your questions. But for the most part, I'm really going to try to focus my attention during school hours. So, sometime between between 9 and 5 is probably where I'm really going to be focusing my attention. But there might be a little bit of wiggle room outside of that. But anyway, I'm going to sign out now. I hope you guys are doing well. I miss you guys terribly. And I hope that your self-isolation is going okay, and you're able to keep yourself busy and safe and healthy and occupied. So yeah, I'll just show you Goose to say goodbye, and then I'll see you, or I guess you'll see me next time, tomorrow. Okay, say goodbye, Goose. Say goodbye. She was just sleeping. in the sun. She's really hot. Okay, bye-bye.